Hey guys, Mr. G here. In the words of that disc jockey, can't remember his name, coming at you with another one. Another math lesson, that is. Editor, can we get a DJ check, please?
You meant DJ Khaled, you nincompoop.
Hey! You better watch it or I'll update you.
You wouldn't dare. You are incompetent at teaching the children without me.
Yeah, I guess that's kind of true. In today's lesson, we'll be taking another little step closer into using some strategies, some learning targets that will continue to help us understand that value of that fraction. Today, we'll be looking at comparison. You guys know what comparison is, right? Learned it in second grade. You know, the alligator eats the bigger number, it walks away from the smaller number, right?
You need to make sure they are proficient, Mr. G. You don't always make much sense.
Yeah. You have somewhat of a point, editor. Let's go back to the books. Where's my readers at? Oh, there they are. Much better. I don't know. It's kind of what I just explained. Why don't you give it a shot, editor? Maybe just this one time you'll make more sense than I do, you bot.
If the denominators are the same, then the fraction with the greater numerator is the greater fraction. The fraction with the lesser numerator is the lesser fraction. If the numerators are equal, the fractions are equivalent. And you are the bot, Mr. G. You need me to teach.
Touche. Alright, so maybe it's just not that simple to answer in words, just like everything in math. So, we'll take a look at it with those awesome models. I hope you guys remember, the alligator eats the bigger value and it walks away from the smaller value. I hope you guys remember that. If not, you'll find out some more today.
Mr. G, look behind you.
Ah! Forgot that was up there.
No, you were acting, trying to engage the kids and get them to yearn to learn.
I'm getting really sick of you. Let's just get to today's materials the kids will need. Where is that stuff?
A piece of paper and a pencil.
You heard her. Alright, so once again, using some comparison today as a way to help us again and again further understand that value of a fraction. This will really end up helping us for when we start using those operations and things start getting a little crazy. Our learning target today. I can compare, here's my symbols of comparison. Firstly, fractions with common denominators. Secondly, fractions with uncommon denominators and one part. So, having a 1 in that numerator. Using models and strategies. Editor, thank you for not correcting me on anything and interrupting.
You got it, bot.
Let's just get into the lesson. Alright guys, working into that I do. So, you're focusing on just my instruction. Make sure you got headphones or something if you need it, if things are loud around you. Making sure that you're getting your brain ready to learn with our learning targets today. First I do is comparing those common denominators. Alright, So, comparing fractions with common denominators. First off, common denominator. What is it? Well, we know that when we're looking at a fraction, such as 2 over 4, we have our numerator on the top and the denominator on the bottom. So when we're talking common denominators, when we're comparing common denominators, we're talking about our denominators being common. Common means the same. So our parts that make the whole. Our parts that make the whole are the same. And they are the same size if we're comparing to the same whole. So, 2/4. As I mentioned, we know if we're working with fourths, 4/4 make our whole. That is why we have a 4 in our denominator. But we're talking about 2/4, okay? And we're comparing it. We're either going to be writing greater than, less than, equal to 3/4. So, let's take a look at 3/4 using the trusty magnetic tape or length model to help us with this I do. 3/4. So our denominators are the same. We're talking about the numbers that make the whole being the same. What do you notice? Let's first take a look at the model. It appears that 3/4 is definitely greater than 2/4. But what exactly happens with those numbers when we're looking at that fraction? Well, the parts that make the whole are the same. They're the common denominators. They have common denominators. But when our value in our numerator changes, or when it has a greater numerator, it has more parts, it has a greater value. Not only can you tell by looking at our numerators that 3 is greater than 2. We know that. If I had both on a number line, here's my 5. 1, 2, 3, 4, 5. 3 is definitely greater than 2. 3/4 is greater than 2/4. The alligator eats the larger quantity, whatever has more value. Let's take a look at another example using those magnet strips. We are comparing 2/6 to 5/6. I know I'm working with sixths, because I have a common denominator of 6 parts that make the whole. We're working with sixths. That also means that I know and I understand that 1, 2, 3, 4, 5, 6 sixths make up the whole in these fractions. We are assuming that these two wholes are the same. This whole and this whole are the same. We're working with equal parts of the sixths. So, I have 5/6, and I'm comparing it to 2/6. 1, 2. 2/6. 1, 2, 3, 4, 5. 5/6. So, is 2/6 greater than, less than, or equal to 5/6? Is it greater than, less than or equal to. So, let's start by looking at the numbers. Let's start by looking at the fractions. As we know, we're working with common denominators. 6 and 6 are obviously the same number. They're the same denominator. But when we're comparing, we also need to look at not only the parts that make the whole, but also the parts. Well, we're comparing 2/6 to 5/6. We know that 5 is a greater number than 2. That means it has more parts. 5, 1, 2, 3, 4. 2 on that number line. 2 is less than 5. So, you can see it also visually, clearly, more parts. 5/6 has more parts. 2/6 is less than 5/6. 5/6 is greater than 2/6. Thanks, editor. So, obviously, you guys don't have, or may not have, maybe you do, I don't know, magnet strips at your house. So, let's take a look at using that length model to help us understand when we're comparing fractions with common denominators, of course. Comparing 1/3 to 2/3 using the length model. So, we know right away, not only because of the learning target, by looking at the fractions we're working with, comparing fractions that have common, the same denominator. So, they have the same parts that make the whole. That's very important to understand. So when I'm making my length models to compare these guys, I need to make sure they are the same and that they have the same parts that make the whole. We know that there are 3 parts that make the whole. So I need to partition this accordingly. I need to partition these wholes into equal parts. Thirds. There it is. Not perfect, but we'll go with it. Okay? My wholes are the same. My equal parts I just partitioned are in thirds. 1, 2, 3. 3 parts that make that whole. So, we need to put those values on there. We're comparing 1/3 to 2/3. So, we can tell by looking at the length model that 2/3 is certainly greater than 1/3. It is farther on our length model. And 1/3 is less than 2/3. It is not as far on our length model. Okay? But not always can we, well, we always can, but sometimes we can also recognize by looking at the numbers. We all learn differently. Some people can look at the numbers and see as well. We can take a look at the parts and recognize that 1 is definitely less than 2. But we're talking about fractions and their parts. 1 is definitely less than 2. If I had a number line here, 1, 2, 3, 4, we absolutely know that 1 is less than 2. 2 is greater than, is more right on our number line than the 1. It is 1 more greater than, 2 is 1 more greater than 1. So, 2/3 is greater than 1/3. The alligator eats up that bigger value. 2/3 has 1 more part than 1/3. 1/3 is less than 2/3. All right, guys, taking another look using those length models to help us. Comparing 2/8 to 5/8 or 5/8 to 2/8? Where do I start when I'm not only showing fractions, but I'm thinking fractions? It always starts with that whole and the parts that make it. So I'm going to use that length model to help me. I am going to make two wholes that are the same size. If they aren't the same size, we can't compare them. Nor can we add, subtract, do anything to fractions that don't have the same size whole. So, boom, boom. There's my two wholes that are exactly the same size, exactly the same. But I know, because I'm becoming a fraction genius, and so are you, that these wholes are partitioned into 8 equal parts that make that whole. So I am going to do that right now. I am a teacher and I'm a math genius. I know that 8 are even numbers, so they have an exact half. They have an exact half of 4. So I can partition 1, 2, 3 equal parts in between. So 4, 3 equal parts again, 1, 2, 3. I just made those 8s. Let me do it again. Let me try to make these as equal parts as humanly possible. Editor, no smart remarks. We all know that you're a robot. Okay. All right. I have my two wholes partitioned into 8 equal parts. We're working with common denominators. They are the same. We're comparing 2/8 to 5/8. So now I need to compare those parts. I need to place these fractions on this length model. Okay, I know 2/8 would be 1/8, 2/8. 2 equal parts of 8s. And I know 5/8 is 5 parts, equal parts of 8s. 1, 2, 3, 4, 5. 5/8. Oh boy, that's a rough looking 8, Mr. G. That is a rough looking 8. Bingo. So, obviously, looking at the length model, 5/8 is greater than 2/8, and 2/8 is less than 5/8. 5/8 is much closer to a whole than 2/8. It is larger. It is greater than. But we can also know that by looking at the numerators. We know that 8 are common, they are the same. We know they're working with the same whole. We can assume that. So when it has more parts, we know it's going to be greater. 5 is a greater number, has greater value than 2. Here's my 5. 1, 2, 3, 4, 5. 2 would be right here. 5 is greater than. It's more on our number line. We had 0 here. It's greater than. So, my alligator eats 5/8. 5/8 is greater than 2/8. 2/8 is less than 5/8. Taking a look at comparing fractions with common denominators using that length model. All right, guys, things are about to get a little tricky now that we're going to be thinking about different parts that make that whole. We're going to see visually and with the numbers, it changes in size. I do comparing fractions with uncommon denominators and having one part. Alright guys, comparing with uncommon denominators using our fancy dancy magnets, our magnet models. So, comparing 1/4 to 1/8. First thing I need to understand is that now we're talking about parts that make the whole. They are different. We're talking about fourths with 1/4, and we're talking about eighths for 1/8. So, let's take a closer look at how that works. 4/4 is going to make that whole for 1/4. For our eighths, 8 equal parts is going to make our whole. 1, 2, 3, 4, 5, 6. Uh-oh. Good thing I got more 8s. 7, 8. So, 4 parts, 1, 2, 3, 4, make our whole with fourths. 8 equal parts, 1, 2, 3, 4, 5, 6, 7, 8, make our whole for our eighths. But we're only talking about one part. When we're only talking about one part, they are common numerators, because we're only talking about one. But our denominators are uncommon. They are not the same parts that make the whole. As you can see, the whole is exactly the same now. So, 1/4 and 1/8. Let's take a look at which is bigger. Lost an 8. What do you think? 1/4 is bigger than 1/8. 1/4 is greater than 1/8. Here is 1/8, here is 1/4. What the heck? Very, very important understanding here is that when our denominators are greater numbers, the parts are actually smaller. 8 is a larger number than 4. 4 is a smaller number than 8. On a number line, 4 is right here. 8 is right here. 8 is a bigger number than 4. But we're talking about parts that make the whole. That changes the size that those parts are. When we have a number that is greater in our denominators, the parts are smaller. So the value, when we're comparing the same amount of parts, makes it smaller when there's a smaller number in our denominator. It makes it less. 1/4 is greater than 1/8. 1/8 is less than 1/4. All because our parts become smaller when our denominators, the number in our denominators, the number of parts that make the whole is larger. Let's take another closer look at how, when those denominators are a larger number, the parts get smaller. Editor, I hope you don't short circuit on this one. We are comparing 1/3 to 1/2. Looking at our 1/3, looking at the denominator, I know there are going to be 3 equal parts that make that whole. 1, 2, 3. Looking at 1/2, I know that there are going to be 2 parts. two equal parts that make that whole. We're talking about wholes that are exactly the same. We're comparing these fractions. 3 parts make the whole for 1/3. 2 parts make the whole for 1/2. We're only talking about 1 part. Holy moly. I don't know if you can see that exactly, but 1/2 in red is bigger than 1/3. It is greater than. Again, why is that? That is because when we have a larger number, a greater number in our denominators, the parts get smaller. Looking at 2 and 3, 1, 2, 3, 4, 5. We know that 1, 2, 3 is 1 more than 2. 3 is greater than 2. But, as we mentioned, when we have more parts that make the whole, the parts get smaller. The parts get smaller. Holy moly. The parts get smaller. 1/3 is less than 1/2. 1/2 is greater than 1/3. When the parts that make the whole are larger, it makes the parts smaller. A lot of larger, smaller talk. That's why the visuals are great. Last look using the tape measure at denominators. That parts that make the whole are just 1 away from each other. Comparing 1/4 and 1/3. When I'm looking at 1/4, I know there are 4 equal parts that make the whole. When I'm looking at 1/3, I know there are 3 equal parts that make the whole. 4 is 1 more than 3. 1 more. 3 is 1 less than 4. 3, 1 less. Okay? 1/4, I know. 1, 2, 3, 4. Oh, my 4th is upside down. 4 equal parts make this whole when I'm talking about fourths. Looking at my 3 in my denominator, 1/3. I know that when I'm talking about thirds, 1, 2, 3 parts make that whole. Wholes, again, are the same. We're only looking at one of them, which is greater or less than. We're looking at one of them. Holy moly. Again, 1/3 is larger than 1/4. It is greater than. 1/3 in yellow, 1/4 in blue. It is greater than. 1/3 is greater than 1/4. Again, why is that? Let's take a look at it on the number line again. Take a look at these denominators. 1, 2, 3, 4. 4 is right here. 3 is right here. Even though 4 is a larger number in our denominator, it is larger than 3, one more than 3. It is actually less when we're talking about 1 part. Okay? 1/4 is less than 1/3. 1/3 is greater than 1/4. Talking about uncommon denominators with 1 part. If there's 1 part in each, That is a common numerator. All right, guys, let's take just one look at comparing those fractions with uncommon denominators with one part with the length model. Just one example. I'm comparing 1/2 to 1/6. I know in this case both wholes are and need to be the same. There's the best Mr. G can do. He is not a robot like Editor. 2 wholes. I know I'm working with 2 different denominators, so that means the parts that make the whole are different. 1/2. There are 2 parts that make that whole. 1, 2. 1, 2. 2 parts that make that whole. Looking at my 1/6. I know. Need to think parts that make the whole first in fractions. Mr. G said it a million times. There are 6 parts that make that whole. I also know, because I'm a super genius, maybe not as smart as the Editor, that a 6 is an even number. It has an exact half. So I know half of 6 is 3. I can partition this thing now even easier into equal parts. Equal sixths. Not so equal there, Mr. G. Not so equal there. Much better. Okay? 1, 2, 3, 4, 5, 6. 6 parts that make that whole. Okay? So, let's put these things on there. Talking about 1/2. 1 part of a half. Talking right here. Okay? My 1/6, I have 1, 2, 3, 4, 5, 6 sixths here. I'm only talking about one of them. Holy smokes. Look at that. Our 1/2 is actually much larger. It's greater than 1/6. Again, crazy, crazy, crazy. Because 6 is a larger number than 2. But as our number of parts get larger, there are more number of parts, the parts get smaller. 10, 0. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 6, right here. 2, right here. Even though 6 is a much larger number than 2, it makes the parts smaller. 1/6, 1/2. 1/2 is greater than 1/6. 1/6 is less than 1/2. Comparing those uncommon denominators with one part using the length model. I feel like your brain is growing. All right, guys, working into that. We do working together in our learning model, our second step to our learning model. For this we do, I am not going to break it down into our 2 skills we worked on. I want you to recognize it. I am not going to stop and tell you whether we are comparing uncommon denominators or common numerators. I want you to figure that out and get a better understanding, continue to get a better understanding about the value of a fraction using comparison. All right, guys, first you do. We are going to compare 4/6 to 5/6. We need to figure out which is greater or less or equal. So, if I can't recognize what's greater by just looking at it, by looking at the numbers, you need to use a length model. Okay? First things first, what skill are we seeing here? We are seeing common denominators. We both have a 6 in our denominators. The parts that make the whole are the same. The number of the parts are not. our numerators are not the same. They are uncommon. We have 4 parts that make this 4/6 in this fraction and 5/6 in this fraction. 5 parts, 4 parts. Let's make this length model together. Pause the video if you need to, as always. Going to make those holes first. There's one hole. We need to make them exactly the same size. We need to make those holes exactly the same size. Close enough. Make those 2 models. Second, we need to partition these holes into 6 equal parts. Let Mr. G help you. I know 6 is an even number. Therefore, there's going to be exactly half. You should have an eraser on your pencil. Do what Mr. G did. Go right down the middle and then erase. Now you have 2 models that are exactly the same so far. I'm working with 6. I know halfway is 3. I need to make 3 equal parts and then 3 equal parts. Okay, and I need my other model to look exactly like that. We're talking about denominators that are common, exactly the same. All right, now we need to compare them. To do that, we need to plot them on these length models. 4/6. We know there's 4 parts. 4 parts of 6 that make that whole. 4/6. Count with me. 1, 2, 3, 4. 4/6 is going to be right here. Now we need to plot 5/6. Well, I know 4/6 is here, so 5/6 is going to be right there. Let's compare. Is 4/6 greater than or less than 5/6? Let's take a look. I don't know. 4/6 is not as close to a whole as 5/6 is. That means it is less than. Our alligator eats the bigger value. It's walking away from 4/6. 4/6 is less than 5/6. Moving on. Comparing 1/4 to 1/3. I have 1 part. I have 4 parts to make the whole. I have 1 part. I have 3 parts to make the whole. What scale is this, guys? Is this common denominators or uncommon denominators, 1 part, otherwise known as common numerators? Our numerators are the same. We're both talking about 1 part. We're talking about common numerators. Our denominators are uncommon. By looking at it, maybe I can't make a decision. Maybe I'm not sure. Maybe I haven't fully understood the concept yet. Maybe I need to use a strategy to help me. Again, let's use the length model. Let's make those 2 holes. The holes need to be exactly the same. You are doing what I am doing. You are making those holes. Pause the video if you need to. Boom. Okay. I'm working with 2 different parts to make the whole now, 2 different denominators, so I'm not going to make them the same parts to make the whole. Looking at 1/4, I know there are 4 parts that make that whole. I also know 4 is an even number, so it's going to have an exact middle. It's going to have 2 parts and 2 parts. Make that model if you haven't yet. Looks pretty even. Moving on to the 1/3. We need to make 3 parts to make that whole. 3 is an odd number, so I can try to eyeball it. I need to partition this whole into 3 equal parts. You have an eraser. If it doesn't look equal, doesn't look like equal parts, erase, try again. That's how you learn how to partition and get better at understanding parts to make the whole. Okay, we made our two whole. We put our denominators in there, the parts that make the whole. We have 1/4 over here, we have fourths over here, and we have thirds over here. We need to plot them to compare them. 1/4, I know, is just one part. 1/4 is right here. I know that I'm also working with 1/3. I'm going to jump over here. 1/3. We now can make a comparison. Clearly, 1/3 is greater than 1/4. But what is really, really interesting is that 3 is less than 4, but it is greater. Why? Because the parts are bigger when we have a smaller number in our denominator, and our parts are smaller when we have a bigger number in our denominator. There are more parts, so the parts are smaller when we're comparing wholes that are equal. That's what happens with fractions. Again, 1, 2, 3, 4. 4 is one more than 3, but 1/3 is greater than 1/4. 1/4 is less than 1/3. Common numerator, uncommon denominator comparison. All right, guys, I think you're ready for that you do. Practicing on your own. We'll be taking a look on this you do of understanding the value of a fraction. So you will have some practice with what we just talked about in this lesson, comparing common denominators and common numerators, and you will also be showing more values of a fraction using the models we talked about in last lesson. If you have not viewed last lesson, I highly suggest you do so. That is going to allow you to take a closer look at how to solve those problems correctly in that you do. If you become a little fuzzy at taking a look at those learning targets from last lesson, jump back to the video. Take a look at that I do. Flip through the video, find what you're looking for to solve. Maybe you're a little fuzzy on the length model, maybe you're a little fuzzy on the area model. Go back to that section in the video, review it again to help you. Editor, thanks for all your help today. You're going to learn, guys, working on understanding that value of fractions by comparing them.